The second type of formula is recursive formulas. So yesterday we went over explicit formulas for arithmetic sequences, and hopefully remember that arithmetic means that there's a constant difference between each term. So we're talking about the same type of sequences today, we just have a different way to write it. So recursive formulas are just different notation, okay? Two different ways to write things. And the notation today is really important that you're kind of paying attention and being very deliberate in how you write numbers and how you read numbers. So the whole notation t sub n minus 1, that whole thing, kind of put a box around, okay? That whole thing means it's the previous term. So that whole thing is kind of like a button that means like your answer from before or your previous term, however you want to think about it. And the formula is a little bit longer today. There's two parts to it, okay? And it's going to be enclosed with a bracket. The first part is just the first term. So T sub 1 here just means the first term is your first piece of information. So hopefully that's easy to remember. And then your second one is your formula. So hopefully remember that this n over here means this is my formula line. This is an entire box. This whole thing means the previous term. And then you have a plus D, which just like yesterday stands for the difference. Okay, over here today you're noticing that this says n is greater than or equal to 2. Yesterday it said 1. Okay, well what it means is I already had my first term up here, so why would I use the formula to find the first term if I already had it? So it means here's your first term and use this formula right here to find everything from the second term and later. So again, you can ignore that. Okay, you don't need to use that for anything. Okay, so if we look at example A, it says find the first 4 terms in this sequence. So the first thing it says is, okay, well, your first term, it gives you. Your first term is 1. Excellent. Now I only have to find 3 more. So now to find my second term, I need my formula. Well, my formula says 2 times my answer or my previous term, okay, answer or previous term, and then plus 4. Okay, and then again, you can ignore this t greater than or equal to 2 part. Well, if I'm on my second term, what is my previous term to the second? Well, my previous term is the first term, and my first term is 1. So I've got 2 times 1 plus 4. So that's going to give me my second term to be 6. So now let's find the third term. I have 2 times my previous term plus 4. Well, my third term, the previous one to that is my second term, which is 6. So that's going to be my 6. So 2 times 6 is 12, plus 4 is 16. And to find my fourth term, 2 times some previous answer plus 4. Well, my previous answer to my fourth term is my third term, which I know is 16. So 2 times 16, 32 plus 4 is 36. So my sequence here is 1, 6, 16, and 36. Okay, so keep in mind your previous term, this one came down here into here. My 6 dropped down, my 16 dropped down. If I kept going, my 36 would drop down. Okay, so it's your previous term that drops down into this answer area, okay, into your formula. So not quite as simple as yesterday because you need the previous term to move on. Okay, so let's try another one of those. Example B, t sub 1 equals 4. Okay, well that's nice. I already know that my first term is 4. Then my formula, so this is my formula, says negative t sub n minus 1. And this whole thing, that t sub n minus 1, means my previous term or my answer. And then it says minus 2. And then t greater than or equal to 2, I'm going to ignore. So to find my second term, it says negative. So negative, my previous term. So that's my 4. Okay, my 4 drops down here, minus 2. So negative 4 minus 2 is negative 6. So now I'm going to find my third term. My formula, negative. My previous term, so my negative 6 is dropping down this time. Minus 2, minus 2. Well, negative 6 is a positive 6, minus 2 is a 4. And my fourth term here, formula, negative, previous term, my 4 drops down, minus 2 is a negative 6. So this is kind of an odd formula that just bounces back between 4 and negative 6. Okay, so this one would not be arithmetic because there's not a constant difference each time, but it is a sequence of numbers. Okay. So if we're kind of thinking about some of the other things we talked about yesterday, I asked you to find things like the 32nd or the 125th or the 50th term. Okay, would I do that today? Well, I'm not that mean, so no, because if I did, that means to find the 125th, you would need the 124th number, which means you would need the 123rd and the 122nd all the way down to the beginning. So I will not ask you to find more than like the first 4 terms if I give you the recursive formula. So let's take a look at example C. It says write the recursive formula. So now we're working backwards, kind of like yesterday, for this sequence. So I've got 53, 46, 39, 32, and 25. So we need 2 pieces of information, just like we did yesterday. We need to know our first term. Okay, so our first term here is 53. And I need to know my difference, just like yesterday. So how do I get from 53 to 46? Or 46 to 39? 39 to 32? 32 to 25? Hopefully you realize that's a -7. I'm subtracting 7 each time. So those are the 2 pieces of information I need. So I can just plug it into that formula. If you need to look back to your notes, go ahead. So it says my first term is my first piece. So my first term here is 53. Then it says give me the formula. So I'm going to write a sub n equals. And then it says that previous term, so a sub n minus 1, take that and do what? Well, we said subtract 7, so minus 7. Okay, this is where your handwriting is going to get really important because if you write this part sloppy, it may look like -1 minus 7. Okay, but you're trying to write this. Okay, so it's your previous term. If you want to put a box around it for yourself so that you realize that that's your previous term notation, that's fine. So then I'm subtracting 7, and then you do have to write for every number greater than or equal to 2. So that's where n greater than or equal to 2 part has to come in. Okay, you don't really use it, but you need to write it because it's part of the formula. So let's look at example D. Betsy borrowed $370 from her parents for her airfare to Europe. She will pay them back $30 each month. Write the recursive formula to describe the situation. Okay, so the first piece of information in sequences is the first term. So my first term is how much I owe. So I owe $370. Okay, then I know that I need to say my formula. I know that previous term thing is going to come into play. So that's that whole previous term thing. And I'm going to owe, and I'm going to pay them $30 each month. So if I'm writing how much I owe, I'm going to owe $30 less each month. So I'm going to subtract 30, and then I'm going to go n greater than or equal to 2 because that is part of my formula. Okay, so how much does she owe after 6 months? Okay, well, month 1 she owes $370. Subtract 340, 310, 280, 250, 210. So and I subtracted wrong somewhere. 70, 340, 310, 280. No, I didn't, but I need one more, so $180 left. Okay, so that's how much she is going to owe. Okay, let's try example E. This one says write the recursive formula for the sequence t sub n equals 3n plus 18. Oh, well, that looks kind of nice, right? This is the formula from yesterday. One line was explicit. Well, I don't really know what this sequence looks like, so before I even start to write my formula, I need to know what's going on. So let's find a few terms. So, like yesterday, to find the first term, I plug in 1, right? So 3 times 1 plus 18, so my first term was 21. Okay, let's find the second term. 3 times 2 plus 18 was 24. And then let's find that third term. So third term, plug in 3. So 3 times 3 plus 18 equals 27. Okay, so now I know my formula goes 21, 24, 27. So I know that I need 2 pieces of information today. I need to know what is my first term. Okay, so I found my first term to be 21. So let's say t sub 1 equals 21. And then I know that my formula says t sub n equals that whole previous term thing. And then I need to know, what am I doing? Well, how am I getting from 21 to 24 and 24 to 27? I'm adding 3. So I'm going to say, okay, plus 3. And then at the end, I need n greater than or equal to 2 because that's part of my formula. Okay, so the tricky thing is you can't just go straight from the explicit formula to the recursive without actually looking at the sequence. So the first thing I had to do here was actually find my sequence, which was 21, 24, 27, and I did that by using the explicit idea from yesterday, and then I transferred that knowledge into recursive. Okay, so they describe the exact same sequence, it's just two different ways to write the same thing. Okay, so hopefully you're going to be able to go back and forth between the two. And then one more story problem. Debbie has 520 books in her library. Each year she buys an average of 50 new books. Write a recursive formula that describes the situation. Okay, so kind of two pieces of information. So first piece of information is how many books? Okay, she starts with 520. You can kind of think of this as like slope and y-intercept. Okay, so this is where she starts. And then the 50 new each, which is normally your slope, is going to be your difference here. Okay, so you can think of it like that if that helps. Okay, so I'm going to take my previous term, a sub n minus 1, and then I'm buying 50 more, so then I'm adding 50. And then I have to add my n is greater than or equal to 2 at the end of that. Okay, and then how many books will I have 10 years from now? So kind of go ahead and figure that out, just count them out, and you should get 970 books. Okay, so that is recursive sequences, very similar ideas to yesterday, only different notation. So, oh, I almost forgot. Please go ahead and answer those two questions today. So what is one question you still have? What is confusing to you? And what is one thing that you can do now? So what are you able to do? So answer those before class, okay?